Hello everyone, here we are with the 25th exercise. For us, another small milestone. Here, from the name Primality Test, uh, I could say that we'll have to test if the number, probably if the number is prime or not, and to do something with that. So there are two friends, Alice and Bob, who are meeting after a long time. As usually, they love to play some math games. This times this time, Alice takes the call and decides the game. The game is very simple. Alice says an integer, and Bob has to say if the number is prime or not. Bob, as usual, knows the logic, but since Alice doesn't give Bob too much time to think, so Bob decides to write a computer program that will help him to get if the number is prime or not. So in the first line we have the number of test cases, and in each test case we read a different number, and if the number is prime we will output yes, otherwise you output no. So we in this exercise we are going to discuss totally the prime algorithm. A number is prime if only and only is divisible by itself and the number 1. So firstly, let's get the numbers t and n. So then we read the number of test cases, and we have the four less than t, the number of test cases, and I read the and I'll make a function. We have the return type, the name of the function is prime, and the input parameter, which will be a number n. So we'll discuss some algorithm using also the optimized one. So firstly, I'm gonna call here if is prime and then cout if this function returns yes. If this function returns true, then we output yes, otherwise we output no, and new line. So in the prime function we said we'll make in dividers, and we'll do something like this. We'll start from 2, and we'll go until n minus 1, not the n, but before that, and we'll say if the number is divided by I, then return false, otherwise return true. The reason I came back here was to see the constraints. If the input number is greater than 2 billion, so we have to use, maybe we have to use different type than integer, but that's okay. We can use integer because the numbers are small. It should be less than equal to the number before the last, and if the remainder is 0, one of them, then we return false. Also we need to pay attention, so the number is different than 1. The number is different than 1, then the number is 1. This algorithm will say that it is prime, but the number 1 isn't prime. That's why we had to add the number 1 there. If we pay attention more closely to this, that the biggest number that can divide a number is the half of that number, because the divisor after the number 1 is the number 2. That's why we don't need that. It returns false. This will take the half of the speed. For example, for the number 1 million to check number 1,000,001 to check, for example, it will take 500 cycles. But there are even more optimizations if we see carefully the numbers. For example, the number 30, its dividers are 1 2 3 4 1 2 3 5 6 10 15 and 30. If we see carefully, the numbers are in pair: 1 with 30, 2 with 15, 3 with 10, and 5 with 6. So what means that for example, if 30 divided by 5 is 6, that implicates that this 30 is equal 5 multiplied by 6, and that the number 30 must be divided by 6 too and keep 5. If using this, we get to the conclusion that a number, if it's not divisible until its square root, if we not find the number which with which is divisible until the square root of that number, then that number is prime. So we don't need to go till there. For example, from the number 1,000,001, the square root of 1,000,000 is 1000, so we tap maximally 1000 cycles, while with the half we tap 500,000 cycles, which is a very faster way of checking if a number is prime. Let's check our primality exercise code. Waiting for the page to be loaded. You paste it there and submit and wait for a response from the server. Compilation error. Yeah, because we forgot to copy the stream line and know how we forgot to copy it from there. Yeah, I forgot it. I didn't use 08 to select all. What's happening? Why it gives the same error? 2 works. 13 no. For 13 yes. Okay, it works. Okay. Submission queue. Waiting now for the response. Yeah, as it says, it's okay. We just forgot to copy that first line. Thanks for watching. We came to the end of the 25th exercise. Don't forget to subscribe by clicking the red button right below the like button, and also you can turn on notification by clicking on notification bell to get notified and not miss the upcoming videos. See you soon on Code Purpose.